So, rational expressions, what is it? We've talked about it last class, but the idea for rational expressions is that you are looking for any algebraic expressions. Like, could be a polynomial divided by monomial, trinomial divided by binomial. Basically, it is any two polynomial put together as a ratio. That's what we call rational expressions. So we are going to look at rational expressions and see how they are defined and how do we make use of them? How do we solve equations that involve rational expressions like the examples here? Once again, every rational expressions will come with a quotient of two polynomial. It could be a trinomial divided by a binomial. You may work with something that involves two variables at the same time, but all of your variables must be integer. They must come with a positive integer. Any exponent that comes with the x must be positive integer. You are not going to work with negative exponent. You are not going to work with rational exponent. Rational exponent as in radical. You are not going to deal with radical for your x, even though it is okay to work with a radical number in front of your x. For the x itself, it must come with a positive exponent, and it must be an integer, or it is a constant. You may end up working with a constant near the end. You may also work with a radical number in front of your x, but the x itself, the variable itself, cannot carry any radical. It cannot carry negative exponent. When we are working with rational expressions, sometimes they want you to find the value, they want you to make some calculation, and all you need to do is to plug in a number. But there are times when you will end up with something that is impossible. Here we're going to see that situation in example number 1 here. Starting with the rational expressions, 3x squared divided by 3x minus 6. If I want to calculate the value of these expressions using this number, all I need to do is to plug in the value and replace all the x with the value indicated. They want us to use -3 for x. Plug it in, work it out. When we square a negative number, it becomes positive. -3 times -3 will give us positive 9. 3 times -3 give us -9. And as you continue to work it out, we end up with 27 divided by -15. And after you reduce it, this is what we end up with. Not a problem. We got some values here. We have a negative value. Try not to turn these numbers into decimal value. If possible, we'd like to work with exact values. We don't want to turn them into decimal. For the next one, when we have 1/2 for x, Replacing each of the x with 1/2, we will end up with 3 times 1/4 and 3/2 minus 6. Now, if you don't like working with a fraction divided by another fraction, you don't have to work on it this way. You can choose to look at this as a division of two rational number, as in 3/4 divided by whatever you see in the denominator. Three over 2 minus 6. Take the common denominator. That's negative 9 over 2. So when you try to divide 3/4 by this number, it will be the same as multiplying its reciprocal. Instead of having 3 over 4 divided by negative 9 over 2, I can turn this into a multiplication and take the reciprocal here. After we reduce the number, this will give us negative 1 over 6, or 1 over negative 6, or negative 1 over 6. They all give us the same value. So we can simplify rational expressions by turning it into a division of two fractions and then turn that division into multiplication at a later time. But there are times when the number that they want you to substitute wouldn't work. Like the next one in the example. If we are to substitute x equals 2, there will be some trouble. There will be some problem with these expressions here. Yeah, 3 times 4, that would give us a 12 in the numerator. But 6 minus 6 in the denominator will give us a 0. And you cannot have a 0 in the denominator. We cannot divide anything by 0. And that means you will end up with an undefined expressions. Or in another word, if we end up with x equals 2, when we have x equals 2 for the expressions, it will turn the denominator into 0, making the whole thing undefined. And therefore, we try to avoid not using this number. Every rational expressions give us something. But there are values that we don't want to use. In this case, we don't want to use x equals 2. When you actually end up with x equals 2, the denominator will turn into 0, making the entire expressions undefined. And this value is what we call the non-permissible value. You are not permitted to use this number here for the expressions. So when we are starting with an expressions like this, how do we know that this number is something that we don't want to use. When you think about the example in the previous case, when you have x equals 0, it will make the denominator turn into 0, and that's the time when we have an undefined expressions. And so if we want to find the non-permissible values, we want to start from the denominator.